Okay, team, back again with a CPA problem. In this problem, we'll be figuring out what the CPA is that a contact may have to us, as well as what the contact's course and speed are. So for the problem today, our initial setup is we will be on course 285 degrees true at 18 knots. Our radar, we will read at 0800 and find that we have a contact bearing 311 degrees true at 18,000 yards. And then again at 0810, we will find the contact bearing 290 degrees true at 12,000 yards. Our objective will be to find the CPA of this contact first. So, the first thing I will do, as always, is remember that anything that touches the center is true. Anything not touching the center is relative. I will plot my own course and speed. So I will use a speed scale of 5:1 and a distance scale, in this case going out to 20,000 is basically my biggest, so I will use a 2:1 scale for distance. I will measure my speed of 18 knots for my course first. 18 knots. And I will mark that off on the bearing of 285 degrees true, the direction in which I'm heading. I will then plot my ER vector lining it up along 285 degrees true. Next, I'll plot the radar fixes that I got. The first radar fix was at 0800 at 311 degrees true at 18,000 yards. So two options here. You can measure 18,000 yards. And mark that out on the 311 bearing. Or you can know that on a 2:1 scale, it is the 9 ring and mark it on the dot for 311. That'll be my M1. At 0810, I now have that same contact bearing 290 at 12,000 yards. Again, my option is measure out 12,000 yards and mark it on the 290 leg, or you can know that on a 2:1 scale, 12,000 yards is the 6 ring on 290. That'll be my M2. I'll also take the time to label what time those happened at. M1 was at 0800, and M2 was at 0810. That way I don't forget the times. Next, I will connect M1 and M2, and I will continue that line down across the paper. That line is the direction of relative motion that the contact will make. To find CPA, I need then to figure out how close that line will come to my ship. The easiest way to do that is to take your rolling ruler, use the protractor in the middle, and line up on 90 degrees along that line. When I am 90 degrees off of me, that will automatically be the closest point of approach to my ship. So I will mark it on the line, and then I will also mark the heading of CPA. So, CPA, I already know, will occur on a bearing of 253 degrees true at a range of, I will measure it, 9,500 yards. So, if the question only asked me to solve for CPA and bearing to CPA, I'm now done with that problem. However, we're going to continue on, and at this point, we're going to calculate how long it will take to get to CPA. At what time will CPA happen? In order to do that, I need to figure out how fast the contact is tracking along the relative motion line. In order to do that, I need to know three things, as always. I need to know a speed, a distance, or a time. Knowing any two of those, I can always calculate the third. In this case, I have time, 0800 to 0810. That's 10 minutes. So I can come down here and I can mark on my nomograph 10 minutes. Next, I know a distance. I can measure the distance between these 2 points and find that that distance is 8,000 yards, just over 8,000 yards. So I will mark 8,000 yards on my nomograph. I can then calculate the speed by connecting the two dots. And I get 24 knots of speed for relative, down the relative motion line. Next, I want to figure out what time this is going to happen. What time is CPA going to happen? So again, I can use that same thing. As long as I know two of the three items, I can find the other. I know how fast the contact is traveling down this line. I just calculated it at 24 knots. The second thing that I do know is I know the distance between M2 and the CPA. So I measure that distance, and that distance comes out to be, looks like 7,200 yards. So coming back here, I can mark out on the 7,200 yard scale. I'll put that right here. And connect the dots again, knowing my speed and my distance. I get a time of 9 minutes. So CPA will occur in 9 minutes from, remember I measured from M2, so it's the 9 minutes from M2. Or I can also say CPA will occur plus 9 minutes, 0819 on the clock. 0819 is the time of CPA. So I've now calculated how close the ship will come, 9,500 yards at a bearing of 250 degrees true, and that will happen 9 minutes from M2 or at time 0819. At this point, I've calculated everything I can know about the CPA. Now, in order to find the course and speed of the contact, I can then use my relative motion line and complete my speed triangle. I will take the relative motion line and I will wheel it over to the ER vector because this one is not true, it is relative, it will not touch the center. So I automatically know it needs to be at the tip to tail. I will then draw that line in the direction of motion. I will draw the line moving from M1 to M2 down in this direction. Oops. Okay. Now, being that it's a speed triangle, I need to add in the relative speed, which I've already calculated as 24 knots. So I will measure 24 knots. I will mark it off on the speed leg of the relative direction. And then I will connect the ships, or the contacts, course, and speed to the line. I'm lining that up. I get a direction of 210, and I measure the leg to determine the contact speed. The contact speed is 21.5 knots. So contact's course is 210 degrees true at 21.5 knots. Knowing this, I now have answered all the questions of the contact's course and speed, the CPA range, the CPA time, the CPA bearing. This should conclude the end of the problem.